Okay, welcome all. Today we are saying something about code optimization. So basically we have seen that there is a compiler whose job will be to transform a source code to a target code. So till now we have seen that yes, there will be semantic translation where you will write some codes depending on the grammar. Whichever production reduces, according to that particular codes can be written, and those kind of code generation can be done. However, with this code generation we can also keep in mind about code optimization, that we should have less numbers of operations, maybe load store operation or any other statements which are executing without need. We can eliminate those statements. So knowing this code optimization will also help you in while programming, right? So let us start with this code optimization. Very simple things as given in the book of Holman. We will see these things like how can we optimize loops. Suppose you have, the first thing we are going to see is loop optimization. So whatever loops are there, for these loops, if at all certain statements are there which are executing without any need, in that case we can do something to optimize that particular code, right? So suppose we have a code, suppose a while loop which is executing suppose a large number of times, maybe suppose 1 lakh or 10,000, 50,000, suppose this many times, and you have certain code here, suppose S1, S2 and so on, and you have a statement, suppose x is equal to y plus z. Okay, here is another statement and so on. In last I is incrementing, right? No problem. So basically we are talking about this statement. You can see this statement is not dependent on I. Okay, so in each iteration the value of x in the value, in the variable x, the same value will be assigned. Yeah, if at all this value y and z are not changing in between, right? Assuming, let us, for understanding this particular thing, we will call it this method as loop invariant. So basically those statements whose execution results are not varying during the loop execution, in that case we should keep such statements out of the while loop. Okay, yeah, if in between these y and z are changing, certain values are there, and so x is going to be updated, then it is okay. But in case this y or z is having the values which were initialized earlier before the while loop, then in this case they are getting the same values, okay, for the variable x. In the second case, if at all these values y and z are changed every time, and the summation of these y and z are kept in x, and this x is overwritten in each iteration, so when the loop completes, x will have the value of final y and z from the loop, right? In that case we can keep this statement after the while loop, isn't it? Suppose For this, what you can do is you can write this statement either before or after the loop, depending on your requirement. If y and z are changing here in the loop, then it should be kept after the loop. If y and z are not changing here, then it can be kept before or after the loop, right? So let me keep it outside, like you can write x is equal to what it was, y plus z, right, and your loop, while your iteration and your rest of the statements s1, s2 and so on. Okay, so here in this technique what we have learnt is those statements which are invariant, okay, within this particular loop, this would be kept outside, or while this iteration, the last value means while this iteration these values are overwritten every time and only the last value is going to survive. In that case also this statement should be kept outside. Okay. The next thing that we can say is suppose loop unrolling. Okay. Okay, should I take green? Loop unrolling. Here what we are talking is, suppose you will have a loop. How many times the loop is executing, you can try to decrease the number of times the loop is executing. Suppose you have a loop which executes suppose 10 times. Okay, I is less than equal to 10, right? In between what it does, it assigns some value in array, whatever value, and that's it. So this statement, you can see these two statements are executing 10 times, no problem. But at the same time this condition is being checked how many times? 10 times, right? So loop unrolling actually tries to decrease the number of test cases, how many times this condition will be tested. Okay, for now we understand that this statement will be executed 10 times. Yeah, it is necessary in this case for storing the values in the 10 different locations. But this condition which is being executed 10 times, can it be decreased? Loop unrolling is this technique which says, okay, there are something that we can do till a particular limit, we can decrease the number, and for that what we can do, we can write it twice in the loop. If we will write it twice in the loop, what will happen? The number of test cases will decrease by 2 times. See, xi is equal to I plus plus, and again xi is equal to I and I plus plus. In that case, this thing which was executing 10 times, now also you can see the values will be stored in the 10 different locations, no problem. But this condition will be executed only 5 times, maybe 6 times, if here it was being tested 11 times. So that is how we are thinking. This was a technique, we call it loop unrolling. The next technique can be loop jamming. Okay. Sometimes it is also called loop combine. By the name you can now understand that when there are two loops and if it is possible to combine them, it is better. Okay, suppose you have something like while for I is less than equal to something, let me keep it a big number, 5 lakh, and we are doing something, suppose x is equal to a plus b into c and I plus plus. We have another loop which says while I is less than equal to same number, 5 lakhs, do what? Do something other, y is equal to something, some value, c plus d into e, okay, no problem, and I plus plus. Now you can see this is another loop which is running for finding the value of x, and this is another loop which is trying to find the value of y, right? Okay, so if it is not changing, let me change it. The value is like this. Okay, so here you can see it is running for 5 lakh times, it is also running for the same time, so just these instructions are being executed, right? So what we are going to do is we will combine this loop. How? We will write the while loop, I is less than equal to your number. You will keep both the things x and y here, a plus b star c, and y plus is equal to c plus d star e, right? Your I plus plus. In this way you have reduced the number of times this was incremented, let it be. You have also reduced the number of times this particular instruction was executed. You had tested 5 lakh times this and another 5 lakh times this, but now since we have combined these two loops, okay, so now you are testing this only for one time, maybe 5 lakh times. Okay, earlier you were testing for 10 lakh times, right? So this is how you can try to find out those places where the codes can be combined to optimize the loop. Now let us talk about another thing other than the loop. You can have something like constant folding. Okay, one method can be constant folding. In this case, constant folding, what will happen? You will fold the things that are unnecessary. Fold, I should say, unnecessary things. So for example, let us assume you have x is equal to a plus b and then some constants. Constants can be suppose 1 plus 200 plus 3. So you can keep these constants together. You might be having something in your logic that this value represents something else, this value represents something else, this value represents something else. So you are keeping it separate, but it is not required. These can be summed together and kept as a single value, right? So for this you can write as x is equal to a plus b plus suppose 204.14, right? That is how you should do. One other thing is copy propagation. Let me show you something about copy propagation. Copy propagation. So what happens in this technique? Actually, you have some expressions like suppose generally it happens with pi. You have pi 3.14. Okay, so you have defined this pi, and then what happens? X is equal to pi into some value. Okay, so what this copy propagation says, in such cases what we can do is we can remove this statement. We do not need, we can write directly x is equal to 3.14 into this thing. Okay, in fact in place of this you can write x is equal to 3140. So this is something. Now another thing we can see is redundancy elimination. Okay, redundancy elimination. Okay, so you can understand we have already seen DAG, data structure, right? Directed acyclic graph, how this DAG can be used here in the syntax tree, right? So it will help you in this removal of redundant codes. Suppose you have example A is equal to B plus C, and B also is equal to something 2 plus B plus 3 plus C kind of thing. Another thing here you can have C is equal to C plus B, right? Okay, so now here you can say this is B plus C. Here also you have B plus C. This C plus B is also B plus C, right? So it is true that you will have to do this once, but not every time, right? So this can be optimized. For this, if you are optimizing such thing, you can call that you are eliminating the redundant things. So for this you can just definitely write A is equal to B plus C, and the next time for B, if you are folding the constant, that is also good. 2 plus 3 is 5, this is constant folding. After that you can add B plus C as you can keep the variable A, right? So you usually do these things, but still what you do is named as redundancy elimination. Other thing is C. Now C also, since it is C plus B, B plus C is same, you can write as A, right? So this is how redundancy elimination is done. One more thing is I should say strength reduction. Some of the operations take means some of the operations are more expensive than others. In that case, this strength can be reduced. Suppose you have one expression which says 2 into I. What does it mean? You are trying to multiply 2 into I. Usually you should understand this is same as I plus I, right? So the multiplication operation is more expensive than the plus operation. So at those places where these are possible, this can be done to reduce the strength. So such optimization technique will be named as strength reduction. One more thing that you can think about is dead code elimination. So what happens, suppose such code which is not of use, which has never been used, they can be eliminated. Okay, so shall we have some example? X is equal to, suppose, subtemporary variable t3, some thing like a_t2 is getting some value of t5, and a_t4 is getting some value of t2, and you are printing the value of t4. So now here you can see this is the statement, a_t2 is getting some value t5, okay, x is getting t3, okay. So now such operation, although this is not that nice example, but still what we are trying to understand is such code, suppose something which is not going to be used anywhere, right? So such codes are dead codes, so such codes can be eliminated. So basically in dead code elimination, what we are trying to understand is that part of code which is not going to be used in your program anywhere, and it is being executed unnecessarily, so such code can be removed. So these are few techniques in code optimization, although definitely new techniques can also be there. So till now we have seen these things: loop optimization, where we will try to optimize the loop with loop invariant or loop unrolling, loop jamming or loop combine, constant folding or copy propagation, and redundancy elimination, strength reduction, and dead code elimination. Okay, thank you.